Okay, so I'm back now with the same script that we were using last time. This is this Aqua Tower-esque script where we're taking some sort of non-normative form and eventually we are cutting it and slicing it in order to create essentially a skyscraper. So it's just really basic geometry manipulation. The thing I'm looking at right now is this part of the function. This is my count of floors. This would be really useful if I had a very limited number of floor counts, but we're starting from a surface that already has a fixed height. What we want to do more likely is make the floor number change with the floor height. So currently, our floor height is controlled by this tool. And what this does is it increases the number of individual planes in an array going up in order to cut these different shapes. As we decrease the number, we decrease the distance between them. But if I go too small, I will run out of floors. I've only got the 19. What I want this to do instead is to extend all the way up regardless of what my floor height is. So instead of using this as just a number slider that we adjust and manipulate here, let's make it a function of both the height of our original object and then the floor height. And so we can basically divide one by the other to get a number that should keep things pretty consistent. So how do we get the height of an object? Well, there's a handful of different ways, but usually one of the more common ones is going to be something called a bounding box. So, by the way, if you see an object in a script and you don't know where it is, which happens to me sometimes, you can hit Control and Alt and then click on it, and it will come up here and just point it out to you. So we're going to look at surface, and then in primitive there's one called bounding box, and I am going to grab that. We are going to make this a little bit larger since our focus right now is this. So currently this has nothing into it. What it wants is some sort of content. So this is just going to be basic geometry. It can be curves, it can be points, it can be surface in our case, and then a plane. Generally, world XY is going to be where you're starting and building a lot of things. We're just going to keep that the same. So all we're going to do is we're going to take our surface, in this case actually it's a capped surface, and plug this in here. So you'll notice that this box covers this thing completely. When I switch between the two, you get that full experience, that full thing, but it doesn't go beyond it. You also notice that the height's going to be the same. So there's a handful of different things, like there's lists of boxes in the orientation, and then there's just the box as a locally defined value. They're going to function the same for what we're doing. So we're going to look at analysis and in particular deconstruct box. So there are some pieces of geometry that are more primitive that are going to have the ability to pull more information out of them. In our case, box is used so frequently to describe things and volumes that there are a lot of tools for it. Deconstruct box is one of them. What we're going to do is we're going to plug the box into here. I'm going to kind of pull this guy up over here to give myself a little bit more room to work with. But you'll notice that I get the plane that it's built on. I'm going to get the X here, where it's giving me a locally defined value from this to this. Y is the same thing. It's from this to this. And Z is from 0 to 250. That's great, but I really want a simple number. What we're getting here is called a domain. Domains are going to be just ranges of where numbers are going. It can be like -5 to +5 or 0 to 1,000. All of your number sliders themselves have domains as well. But those domains almost always are going to have two numbers, unless they are a double domain, which will have 4. But we're going to have to figure out a way to pull that number out. So believe that is in maths and then domain. There's a handful of tools here. So generally, we made a box and then we deconstructed it and we look for deconstruct box. Now we have a domain and we want a part of it. We're going to want deconstruct domain. So we've got this base number, or this base domain, and it's going to give us a start and an end. So in our case, we're looking at height, which is going to be in the z direction. We're going to plug that in. So the start is 0 and the end is 250. In our case, we can just use the 250, but if you needed an absolute height, say your thing went negatively into the ground, you would need to do another function here. I'm just going to go ahead and do that as good practice, because if I want to use this component somewhere else, it will just work on it. So once again, we're in maths. We're just doing basic math. I am going to take subtraction. So remember, your height is going to be your top point minus your very bottom point. In our case, that's the end of the domain minusing the start of the domain. So subtract, and you'll get A minus B. They do go in order, so just remember it's A minus B. So we want to put this up here, and we want the top minus the bottom. So our result is still 250. But if we had moved our surface down, it would still result in 250 as opposed to just being where the top of the box is. Okay, so we've got what the height is. Now we need to divide. Once again, it's just in math. You'll see this A over B operator. It's not the symbol that a lot of people use for division, the two dots in the bar. But once again, it's going to be A divided by B. So we have our total height, which is 250. And we want to see how many 9-foot floors, in our case, go into there, or 9-unit floors, whatever. You might be using meters. So we're going to take this number, A, and divide it by B. Okay, so we have 27.7778. So once again, so just like whenever we average how many children families have, rounding makes more sense than not. Like, you can't have 0.778 children. You can't have 0.778 floors. It's either a floor, one more or less. So there's actually a tool to round numbers. We're just going to look for it real quick. Yeah. So, and it actually is pretty common. So it's just called round. This is going to be in math again. It is under utilities. I almost never remember where this is specifically, so I just type it in. But remember, Control and Alt and clicking will show you where a component is. So if we put this in here, so first of all, there's a number goes in here, and there's going to be the nearest one, which is how we traditionally round. You know, if it's 0.5 or greater, it goes up. If it's 0.5 or lower, it goes down. If it's the floor, it will round it down always, and if it is the ceiling, it will round it up always. In our case, we always want to include that top one, so we're actually going to want the ceiling. Funnily enough, it also works for skyscrapers to call that the ceiling. So where does this number now go to? So we were originally using this, like different, 20 to as the number of floors. This is basically creating an array of planes that we then cut the shapes with. We're just going to want to replace that number with this number. Okay. So now that we've made this more complicated, all the wires start going everywhere. So if you're OCD like me, and I'm not that OCD actually, then this can get a little confusing. I'm going to go ahead and group this because this is like a function. This is like a big thing. And I may want to move the whole thing more or less or use it in another project. And where's a good place to put this? We're going to move this thing up because I'm not using it that much right now. And move this one down and move this one just on top of it. So this is a little bit easier to read. Not a drastic amount. Okay. One other tool to remember, and I don't remember it that often, is called parting. We call it the Moses tool. It's parting the Red Sea. If you hold Alt and you click, you can increase or decrease the length of everything up and down, or left and right, or up and down by hitting Alt. So in our case, this is more useful for me because I can kind of start pulling and organizing things a little bit better. It just makes these things longer. So we created that number. We're plugging it into this array to cut things. And then now, if we've done this right, we should always get the right number that we're looking for. You'll notice too that now whenever I've increased the size, my tool here is no longer giving me an error. However, we do have a different issue that crops up. So now, whenever we use this, if something doesn't round correctly, it will go above that top limit. So if you're working in a development that doesn't allow you to have something above a certain height, this is bad. If you forget about this at some point, you may be giving somebody a floor that is too tall. In our case, we could then measure to the floor instead, and it would do the opposite, where now it will never go beyond that top portion. And obviously I'm getting an error because I'm getting divide by 0 there. But yeah, that's just a simple way to go about creating a function with really basic math. Stuff that you would be doing by hand normally if you were just trying to figure out how many floors to fit in a space. Now, if your floor height changes, you don't have to worry about it. You can just change it and this will take care of it for you. So likewise, this is going to apply to the other components that we use too. So it's going to change the amount of those floors that we have, those balconies. And so as we increase or decrease this, it will all match up because they're all based on the same function in the beginning. Okay? I hope that helps, and I'll see you next time.